right, on day 2, we're going to do examples, obviously with much higher powers of x. We don't know how to factor this necessarily when we have 5 different terms, so we're going to have to rely on the calculator to help us reduce or break these down. So the first thing I'd like you to do, please, is to plug in f of x into the calculator. I want you to do it, and I want you to verify that what you get is the picture that you have in your notes. Have it. As I told you, if we're dealing with higher order exponents, so we're talking x to the 4th, x to the 5th, you're going to need a method. I'm either going to have to give you a table or you're going to have to use your calculator to break it down to get it all the way down to quadratic. The highest level equation solving that we really work with is quadratic. Even a cubic equation will probably have GCF factoring to go from x cubed down to x squared, and then we can move forward from there. So if I have x to the 4th, when I look at the diagram, does it look like it has, or the graph, 4 zeros present? 4 solutions, 4 zeros, 4 x-intercepts. The question is, are all of those integers, or are they not? So if I go into my table, you'll notice that I have how many? How many zeros are clearly present in the table? 2, right? I've got this one. And I have this one. Okay. Everybody table, second graph. Anyone have issues that your table doesn't have integers in it or nice numbers? Okay, so from there it tells us this. Let's go back to the example I have on the right-hand side of the board where I have the number 30 written. We know that 30 is 2 times 15. But we also know that 30 can be broken down by 3. In essence, by looking at what we have in our table here, we're determining 2 different divisors that go into the original problem. So 2 and 3 both divide into 30. -2 and 1 in their factor form will both divide evenly into this function. So what we need to do is we're going to use synthetic division to actually divide in and break down this f of x.
All seniors, please report to the gymnasium. Please bring your picture order forms if you have them. All seniors, please report to the gymnasium and bring your picture order forms. Thank you.
All right, so what we're going to do is we're going to take our function, 4, 3, 2, 1, 0. All powers are represented, and we're going to write our numbers, 1, 1, -5, -3, and 6, and we are going to synthetically divide by the first factor. Remember, we synthetically divide by the 0 value, but what we're really checking is we're dividing by x plus 2, the factor. If we were doing long division, that's what we would do. So I draw my line. Down 1. Notice I have a 0 remainder. This is where we really need to go back to what we did here in red when we broke down the 30. So when I broke down the 30, if you recall, I said I took out an x plus 2 by doing the synthetic division. What I'm left with is, this is x to the 4th, this goes down to x to the 3rd, x squared, x, and a number. So that technically could go here if I wanted to only take out one factor. But I don't want to do that. Now what I want to do, I'm going to erase the red, unclutter all of this. I now want to synthetically divide by the next 0, which is 1. I didn't go back to the original function. I went down to the broken down function, just like here. Once I took a 2 out of the 30 and got 15, I then took the 15 and continued to break it down. It's the same process. So I draw my line, 1, 1, 0, negative 3, negative 3. Notice I get that happy, no remainder left over. By dividing by this 1, I'm really checking an x minus 1 division. So I've now taken out an x minus 1. What am I left with? Well, I started with x to the 4th. I went down to x to the 3rd. Now I'm at x squared, 0x minus 3, which gives me x squared minus 3 left over for the factored form. Does that make sense? All right, are there any questions on the breakdown of f of x? Bless you. All right, so if we look back, what do the directions say for example 7? What are you asked to do? Are you asked to write the function in fully factored form? What are you asked to do? For number 7? And find all of the exact zeros. Okay, so the other thing we can do is we can say, look, this is x to the 4th. So if I'm looking for zeros, 1, 2, 3, 4, I will have at max 4 of them to fill in. Did you find any in the calculator? What are they? Negative 2 and 1. That tells me I have 2 more. Where am I going to find the 2 more? From the purple. This is a quadratic. What are the solutions of this quadratic? X squared minus 3 set equal to 0. X equal to? It's also minus root 3. So that's where this comes from, the root 3 and the negative root 3. And there are my 4 real exact solutions. Questions? All right, any other questions? You feeling good? Makes sense in your head? A lot of work, a lot of thought process involved, but if you go back to what we know with numbers, I think it does kind of match up very, very easily. All right, let's look at the last example. The last example is an example of a double root. So we're going to come full circle with our polynomials. We're going to go back to lesson 3. In this example, what are you asked to find? What do the directions say? Example 8. This gives you a graph and the directions for, it's going to be the same as 7. So we're going to find all the zeros exactly, and we're going to write this in factored form. Okay? So the first thing, which we actually did this last, was we said, you know what, looking at the highest power, how many zeros should I have? 3. Okay, 1, 2, 3. Looking at the diagram that results from your calculator, how many zeros do you see? That's the calculator picture. How many zeros? Jordan? 2 of them. Okay, so then we go into the table. Fantastic. So we go into the table, and I find a 0 where? At 3. now I'm going to put a star by this one. The reason I'm putting a star by this is what? What do we know about the 0 at 3? Look at it. This is an example of a what? A touch. Right? Touch or tangent is the better word. What happens when a graph touches and bounces back off the axis? What do we know about the multiplicity? It's even, which means it's going to be how many of them? How many times does the 0 count? 2 or 4 or something higher. Since this is only degree 3, I know that this one and this one are both going to be 3. Those of you that all of a sudden checked back in, you wrote the 2 3s. Do you have questions? You can phrase why I wrote 2 3s there. Yes. Why did I write 2 3s there? Look at the diagram. This makes sense, right? That this is a 0. When I look at 3, the graph touches. Which, remember from the other lesson, when it touches, it counts twice. You write it twice, it counts twice. It could count 4 times, but we know it doesn't because it's only degree 3. Okay? It's going to be a touch. So now the idea here is we're going to use synthetic division, which is our fastest method to do this, and we're going to synthetically divide by 3 twice. So I'm going to take 6, negative 31, 24, and 45. Do I have every power represented? X cubed, x squared, x in a number. I have 4 of them. And quickly, all of these should come out to 0 unless I'm doing something wrong. 6, 18, negative, what, 13? 13, negative 39, negative 15, negative 45, 0. Synthetically divide by 3 again. 6, 18, 5, 15, 0. Happy face. What am I left with? 65. 6 and 5. The answers are 3, 3, 6, and 5. No. What are they? Let's go back to the original directions. It said to rewrite in factored form. So based on these 2 zeros alone, this is the same thing as x minus 3. X minus 3 times what? What goes in the purple parentheses? This goes down to x plus 5, so this is your 6x plus 5. So what is my other 0? Exactly. Negative 5 over 6. That's the whole unit. That's everything. You feel like we came full circle? We started with quadratics, and then we went to higher order. Now we came back around, we did some algebra in between. Learned some vocabulary with factors and zeros. Still used all the quadratic strategies. Yes?